morning, Nathan. I did not get this. I was supposed to stay yesterday and do it after school. And it got to be 3:30, and I just got tired and I went home. Which I know I'm probably supposed to do, but here lately I've been staying till like 6 and 7 o'clock at night. Just wasn't happening yesterday. I was worn out. Worn out. Sorry. Anyhow, starting chapter 3. So there's going to be 2 tests on chapter 3. So we used to always call it chapter 3A and 3B because they're kind of, they're related, but it's enough of a difference that you need to split it up and have 2 different tests. So this is the start of chapter 3A. That just made me think, I don't know that I've been putting tabs in your notebook where the chapters start. I need to do that. If I forget to, remind me. Okay, so we start out with just some basic vocabulary and all. If lines do not intersect, then they can be classified as one of 2 types of lines. Okay, so first, parallel, which you already know about. So these are lines in the same plane that don't intersect. So they're going to be in the same plane. They do not intersect. And remember, for everybody to know that they're parallel, you put that extra set of arrows on there. So let's say we call this line L and this line M. So you could say that line L is parallel to line M. Now, when you typewrite, that sounded weird. Typewritten, it looks like the lines go straight up and down because you can tell a difference between that and an 11 or any other kind of mark. Usually when I handwrite them, I slant them just a little bit because otherwise I think it gets a little confusing, or at least it does in my head. So the definition of parallel lines, so definition, parallel lines is its coplanar lines that do not intersect. Okay, so, but here's why you can't just say lines that don't intersect are parallel, because not all lines that don't intersect are parallel. The other kind of lines, those are skew lines. So these are lines that aren't in the same plane that don't intersect. So that would be like this line, I don't know what we can call it, line J maybe, and then this line, which is in a totally different plane, maybe we call that line K. Those would be skew lines. They do not intersect, but they're also not parallel. So definition of skew lines is it's non-coplanar lines. You don't even have to say that they don't intersect, because if they're not in the same plane, they are not going to intersect. Okay? Now, you do have to be careful. This is where it'll trip people up. I'm just going to come over to the side. And you might have one line going like this, and then another line and you say, okay, that point A, they intersected. And people will go, well, those are skew lines because they're not in the same plane. Oh, but they are. It's just like they're in that plane. So if lines intersect, they absolutely are in the same plane. You can find 3 non-coplanar points in there. Or no, sorry, non-collinear points, which makes them coplanar. So it doesn't have to be just the plane that's drawn on the paper. It's just, are they in the same plane? So you don't technically have to say that skew lines don't intersect because they're non-coplanar, which by definition makes them not intersect. Okay, so here's just, stop the video for a second. Just see if you can figure out what word goes in all these blanks. Okay, so I'm assuming you stopped it. And you're going to check. So if planes do not intersect, then the planes are parallel. So that's like, you've got one plane and another plane, and they never intersect, and therefore they're parallel. You can say that they have parallel planes. Oops. Okay. Planes cannot be skew. Only lines are skew. All right. if two planes are parallel, then any line in one plane will be parallel to the other plane. And I guess, yeah, I would say any line. We don't have to say any lines. So any line would work. So like right here, plane S and plane T are parallel. So we could say plane S is parallel to plane T. So any line that is in plane S will be parallel to plane T. So you could say that J is parallel to plane T. Okay? All right, so given two parallel planes, a line in one plane is not necessarily parallel to a line in another plane. So even though the lines in, like if you take a line in a plane where the plane is parallel to another plane, that line will be parallel to the other plane. However, any two lines in those parallel planes don't have to be parallel. And more than, there's a good chance they're not. So like, let's see, what's a good example? Let's say you took line DA and line AG. All right, so we could say that's a line up here in this top plane. It's a line in the bottom plane. But those two lines are still parallel to each other because they're parallel lines that are in this plane. Okay? If you did something like, what if we took maybe a line like this and then a line like that? Now those would be non-parallel lines. They're in two different planes. But you could also do stuff like, let's say you take, come here, this line and this line. So they are in those two different parallel planes, but they're still parallel because there's a plane that runs like this, that both those lines are in and they don't intersect. So those two lines would still be parallel. So basically, it's just, you just got to pay attention. And then here's like big terminology here, not terminology, but just kind of a fact. A line and a plane are parallel if they do not intersect. That's what determines whether you call them parallel or not. Okay? All right. So far I'm figuring you're like, this is pretty easy, Miss Brent. So this one, here's theorem 3-1. So if two parallel planes are cut by a third plane, then the lines of intersection are parallel. So we used to always talk about, like, you ever seen like a big block of Velveeta cheese, which you may not have because y'all don't eat processed food, I think. And I don't know that you can get more processed than Velveeta cheese. But like, if you've got this big block of cheese and you chop it here and you chop it there, like, it's going to be parallel. So if you've got these two parallel planes, so say X and Y are parallel planes, and you intersect them with a third plane, then those lines right there where they intersect those two parallel planes, those will be parallel lines. Okay? All right, and then, again, this is a theorem, so we need to prove it. So here's what we've got. So what's going to be in the given, remember, that's always the hypothesis. So we've got to have all that in here. So it says, we're going to have a picture. So if two parallel planes, so we've got two planes, X and Y, we say they're parallel to each other. So it's like this statement takes care of this. Two parallel planes are cut by a third plane. So we've got this third plane, Z, coming through. that intersects X in line L. It intersects Z in line Y. So these two take care of the last part of the hypothesis. So we're going to take and put, I'm going to split it up. Like I told you, I like to split my givens. Whatever part I think makes more sense to me at the moment, that's the part I'm going to look about. So I'm going to say that L is in Z and that N is in Z. So I'm saying line L is in plane Z, line N is in plane Z, because that's given. That's basically what those two say in a shorter way. Now, because they're in the same plane, then we can say that L and N are coplanar, because that's the definition of coplanar lines. It's two lines that lie in the same plane. Okay. Then I'm going to come back and I'm going to grab the other given, which is that L is an X. That actually is part of these two still. So I'm going to say L's an X, N's in Y, and the X is parallel to Y. So that's the rest of what's given. So the first part, I took care of, there's line L, it's in plane Z. Here's line N, it's in plane Z. This takes care of the first two steps in 3 are line N's in Y and line L's in X. And then I'm pulling in the parallel part. So that's all still part of the given. So where I'm going next is that L and N do not intersect because of the definition of parallel planes. Because what that definition is that parallel planes do not intersect. Okay, and so if plane X and Y don't intersect, then lines in those planes also can't intersect. So that's why we can say that's the definition of parallel planes. But that leads us to saying that line L is parallel to line N because of the definition of parallel lines, which was coming from steps 2 and 4, because coplanar lines, because they're coplanar and they don't intersect. Okay. So to me, I think the more obvious a theorem is, I think the harder it is to actually prove. Does that make sense? Like, it kind of just slaps you up. It's almost to the point where it's almost a postulate. Where postulates, like we don't have to prove those because they're so obvious. Like, there's a few theorems in my mind that kind of feel that way, and this is one of them. It's just like, well, yeah. So I think those are the ones that are a little bit harder to prove. But technically, we've proven it now. So from here on out, you can say this theorem anytime you want. So if two parallel planes are cut by a third plane, then the lines of intersection are parallel. Okay. Now, here's the part you're already going to know, because we did this last year. So we're going to take just two lines. So now, also, the lines do not have to, I'm still in a highlighter. The lines do not have to be do not have to be parallel. And I almost wish, because gotta blow a nose. We all used the same notes. And we had this one teacher, her name was Miss Manton. I'm just blowing my nose away. All right, but Miss Manton was quite difficult. She was a hard lady to work with. And sometimes, I just didn't change stuff for from her notes because I just knew it would upset her. And I probably shouldn't have said that because this is going on YouTube. And I hope that she doesn't hear that. But I wonder if I could delete this. I don't think I can. And I'm not starting over. So, anyway, I should not have said that. So the lines do not have to be parallel. But this was the picture that she had. And so I just used it. But, like we did this last year where we would draw it. And, you could have a line looks like this. And another line looks like this. And then we come through the third line. So don't think they have to be parallel for this vocabulary to hold up. So let's say we call this line L. Oops. Let's call this one line J. We'll call this one line K. Okay, so a transversal is a line that intersects two or more coplanar lines in different points. So here's that line. It hits the other two lines. And this is a little bit better definition than what we used last year because we were basically like, it's just a line that crosses two other lines. Well, that's not good enough in geometry. So it's a line that intersects two or more coplanar lines. So lines L and J are in the same plane. It intersects those lines in two totally separate points. Okay, so you can't just say it intersects them both because if it went through the same point, then it wouldn't be real useful. Okay, so let's just number these up. So you got angles 1, 2, 3, 4, 5, 6, 7, and 8. All right. So again, you already know all this, Ethan. Interior angles. That's going to be angles 3, 4, 5, and 6. Okay. Exterior angles. And I'm not even really explaining this because I know you know all this already. Like we spent a long time in 8th grade or actually 7th and 8th grade, making sure all this made sense. So there's your exterior angles. So they're in between. Interior angles are going to be the ones in between the two lines that are getting intersected by the transversal. Exterior angles are going to be the outside of those two lines. We've got corresponding angles, which again, like we would just say, they sit in the same place, like top right corner, top right corner. Again, I'm not spending a lot of time on this because you already know it. So it's angle 1 and angle 5 are corresponding. Angles 2 and angle 6 are corresponding. Angles 3 and angle 7 are corresponding. And angles 4 and angle 8 are corresponding. We've got alternate interiors. Oops, probably would help if I could spell. Oh my gosh. Pretend like you didn't see any of this. Okay. Alternate interior angles. So that's going to be angles 3 and 6. Or angles 4 and 5. We can do alternate exteriors. So that's going to be what? 1 and 8. And 2 and 7. And again, I already know that you know why they're called that, so I'm not spending much time on it. So remember, you alternate sides of the transversal, and you go from one of the coplanar lines that's getting intersected by the transversal to the other coplanar line that's getting intersected by the transversal. We also have same side interiors. So same sides would be, what, 3 and 5? And then 4 and 6. And then we could do same side exteriors. And that would be 1 and 7. Oops. Or 4 and 8. Okay, so all just vocabulary. All vocabulary you already know. So here's basically what I want you to do. I want you to just go through and stop the video, try these, then come back and check them. So, again, I'm assuming you stop the video and you try it, and now you're checking to see your answers. So we've got angle 6 and angle what are alternate interior. So I like this picture because these, you don't have to have the parallel lines, but I am going to do this. So if you're looking at angle 6, we're hunting for alternate interior angles. Okay. So I've got those two lines with this transversal. I could do that, and then angle 6 is an interior angle. So angle 6 would be an alternate interior angle with angle 9. But there might be more. What if I used this, and this is my two coplanar lines, and that is my transversal? So if I were to do that, then angle 6 and angle 3 are the alternate interiors. So if you didn't find more than one, stop the video again and then go back and look through here and see if there is more than one. So it's basically find everything that it could be. Okay? So again, I'm assuming that you stopped it. So let's see what we got. Angle 7, we want same side interior. So where can I make angle 7 an interior angle? Okay, right there. So if I'm doing same side interiors, I could do angle 7 and angle 11. That would be one. Is there another way I could have angle 7 be an interior angle? There is. If I use this and this is my lines getting crossed by that transversal, then 7 and 6 are my same side interiors. Okay. All right, next up we need angle 4 to be a corresponding angle with something else. So where's angle 4? There it is. I could do this line and this line with this transversal, and then 4 and 12 correspond. But I could also use this line and this line with this transversal, and then 4 and 2. Are the corresponding angles. All right, just for time's sake, I'm just going to go through here and write down. Well, actually, I guess I should probably do one more, because the next one, I want same side interiors, and one of them is angle 5. Okay, so angle 5, there's only one way to make angle 5 an interior angle. That's if I look at these two lines with this transversal. So 5, what do we want? Same side interiors. It's only going to go with angle 9. Like, if you use the other two lines with the transversal, then it's not an interior angle. So, like I said, for time's sake, because I know that you understand this. So I'm just going to go through here and fill in all the answers from my old notes. And then if you don't see why it's what it is, get me back there while you're taking notes. And also, if you think I missed one, get me back there, because again, I'm not talking it through. I'm just writing down what I had on notes from years past. So just in case I made some silly mistake. Let's see, here's 8 and 14. And what I'm writing is, this is the and symbol, and then I'm putting angle whatever. Okay. So this one, it looks like it was only angle 15. This one, angle 15, or you could have angle 5. And maybe, you know what? I'm changing my mind. I shouldn't put the ands. Oh, I didn't even close the parentheses right there. I'm going to get rid of all those ands. And my guess is you've already thought about that and been like, Miss Brown, I'm not sure you want the word and. Let's put or instead. So, wait. Number 2. So, it's like 16. What's that all about? Let's say or angle, let's see, 11 and 6. So let's put or, because I think or is the better word. Let's not do the and symbol, because that makes it sound like all three of them are, and Lord knows we had enough trouble last year talking about ands and ors. All right, let's see, 10, I had either angle 9 or angle 3. Hey, I got SNEs. Oh, goodness. Okay, so this one I had angle 15 or angle 5. This one I had, excuse me, angle 15 or angle 5. Okay. so name the transversal and the two lines that form each pair of angles. Then identify the pair of angles as same side interior, alternate exterior, same side exterior, or corresponding, or none of the above. So we're going to take that same picture up here. And it's much easier for me to do this on an iPad because I can do the highlighter. I will say this, when you get tests or quizzes on this chapter, I like to give, like if there's one diagram and I ask a whole bunch of questions about it like this, I will like cut and paste that picture in a whole bunch of times because personally it helps me to highlight. Like I like to do the two lines and the transversal and the two lines in one color and the transversal in the other. We used to, at Brebeuf, before that I started cutting and pasting, we would actually give out dry spaghetti noodles and they would use that. So they would lay it down so they could see which two lines and which transversal we were talking about. Which dry spaghetti noodles works pretty well. I just don't want to bring it down here because I think it'll make the cockroaches infest back here in this corner. And we don't need that. That'd be gross. All right, so we're going to form angles 6 and 7. So what it is, you've got to be able to create both angles 6 and 7 using just two lines and a transversal. Okay, so this line is one side of both 6 and 7, and then these two lines would form the other side. So 6 and 7, the transversal would be line K. The other two lines would be lines L and M. And we would call these same side interiors. Okay, so we'll do, actually let's do one more together and then I'm just going to let you stop and try them all. I'm going to skip to number 16. Okay, oops. So on 16, we're trying to do angles 10 and 1. So we're looking at this angle and this angle. Okay, so how can I make two lines crossed by a transversal create those two angles? Okay, there's the lines. So I could definitely say I've got lines K and N. Oh, that's transversal blank. K and N right here. The transversal would be line L. But if you're trying to figure out, oh wait, oh dadgummit, sorry about that. I didn't, when I reformatted it, 18 went to the next page. That's confusing. Sorry about that, Ethan. But this is an exterior angle and that is an interior angle. Like these don't have a name. So that pair, we can't call them anything. So what I want you to do now, again, I know that this is good because I'm one of the ones who's taught this to you before. I know you got it. So pause the video, and then I'm going to write down the answers, and then you can just come back and check. And again, if you have any questions or you think I missed one, because I am just sitting here copying them now, let me know. So these are corresponding. But instead of walking you through them all, I kind of think that might be a waste. I think you're good. So K and N, these are alternate interiors. But make sure that you've stopped and you've tried this on your own. And you're just checking right now. That looks not like the word interior. Let's do that again. Okay, 17, it was M was the transversal, and K and N. And these were same side interiors. Because I've got to look, and I've been talking for, I don't know, 9% worth on the iPad, so it's been a while. I think I got started this at like 6:15 or so. It's already been 30 minutes. So I think we can probably speed this up just a little bit. And then 18, the transversal is N. The two lines are L and M, and these are alternate exteriors. So again, please let me know if you think I missed one, because I could have just sat here and copied down wrong. Or sometimes I just have brain farts and I don't even know what I'm thinking. So let me know if I missed one of these. All right. So for 19, 20, 21, let's see what's going on here. It says J, K, and L are coplanar. Name the transversals. So 2 lines. I like that green. I like that green better than the one I've been using. Cross. Oh, I thought I changed it. Cross by the transversal. So L's the transversal. All right, this one we need. Ooh, this one is depending on how you look at it. Okay, so like if I said, here's line J. Here's line. Oh no, J's the one going up and down. Sorry. Oh, that's confusing. I'm gonna move these. So let's say, okay, this is line J. That means this one has to be line L. And this has to be line K. Those are in a weird placement. I don't like that. So I think I can see it now, though. So if I did like, all right, what if we looked at this line and this line? And I used this one as the transversal. Okay, so J can definitely be a transversal. Let's make those go away. What if I used this line right here? Let's see, how am I going to do this? So J definitely a transversal. If I wanted to say this was the transversal, then I'd be looking at that line and that line. Okay, so L could be a transversal. So you don't have to, you just only look at the parts that you're worried about. Okay, and then can I make K a transversal? I sure can if I look at this line and, oh, not that one, because I'm not crossing right there. Well, in different places. It's still crossing them both. So all 3 of those lines could be used as transversal. This one, none of them can be, because they're all crossing each other at the same point. Like, you have to create those 8 angles, or we're never going to use the word transversal. That'd be kind of crazy. All right, so this one, name the 2 lines in the transversal that form each pair of angles. Then give the special name given to those pair of angles. So we're doing the same kind of stuff. We're hunting for angles 11 and 1. Okay, so here's 11, here's 1. So we need 2 lines and a transversal to create those 2 angles. So let's look at this line and this line with that transversal. Okay, so the lines would be A and B. The transversal would be C. And let's see, if I just look, like, you gotta, here's what you gotta do. You have to pretend like all this other stuff's not there. So you just zone out. Or zone out, that's not the right, zoom out. And just ignore everything but what I'm looking at. So angles 1 and 11 would be alternate exterior angles. All right, so you may have to do a bunch of erasing to do this. I kind of wish now, though, I brought the spaghetti, because that was helpful on the notes, because we only put it in there one time. But I think that you're going to be fine. So let's do the same thing. Stop the computer. I'm just going to sit here, or stop the video. I'm going to sit here and write these down, and you come back and check them. So for 23, again, did you stop the video? Make sure you did. Alternate interior angles. All right, I am going to talk about this one. So 9 and 8. There is no way of drawing those 2 angles unless you use 4 lines. So this has nothing to do with a transversal. Like, you can't create those 2 separate angles with just 2 lines in transversal. So we don't use any of this terminology there. But check all your work for these other ones. So this one, I said the lines were C and D. The transversals B, and these are corresponding. Okay, 13 and 12. So we have A and B. C, same side interiors. Okay. Dang it, I'm all off again. So B and E with C as the transversal, and these are alternate exteriors. That does not look like exterior. Gosh. Whew. And then this last one looks like B and E with C as the transversal, and they're making alternate interior angles. So today's notes are probably going to take you a while because you're doing a lot of stopping and trying them on your own and then just checking your work. So I probably need to rethink what I told you to do today, because it might take you all period to actually do these notes correctly. And if you try to rush through them, I don't know that you're going to be doing them correctly, because I've been talking for, it's coming in on an hour now, and we're still not done. So yeah, I don't want you to get like in a big old hurry. And let's see, we made it to the true false. A transversal, okay, do the same thing. Stop the video, try these, come back, turn it back on, check your work. A transversal intersects only parallel lines. That is absolutely not true. Skew lines are not coplanar. That's true, because that's the definition of skew lines. If two lines are coplanar, okay, let me think about this. If two lines are coplanar, then they are parallel. No, they could be, but just because they're the same plane does not make them parallel. If two lines are parallel, then exactly one plane contains them. Now that is true. All right, so skew lines are parallel. We're to always, sometimes never. Yeah, never parallel. Two parallel lines are coplanar, always. A line in the plane of the ceiling and a line in the plane of the floor are parallel. Sometimes. More often than not, they're not. Two lines in the plane of the floor are skew. Well, that's never going to happen because they're in the same plane. And skew lines are non-coplanar lines. A line in the plane of the wall and a line in the plane of the floor are parallel. Okay, sometimes it could be. A line in the plane of the wall and a line in the plane of the floor are intersecting. Okay, sometimes could. And this always, I remember it from that class. I used to go around the room and put tape on the wall because some kids would have trouble seeing it. So I'm not doing that for you. So if you have trouble seeing any of these, stop me and I will put tape on the wall so that we can explain it better. A line in the plane of the wall and a line in the plane of the floor are skew. Okay, well they could be because they're two different planes, but they also could be parallel to one another and be in the same plane. So how about we put sometimes? And sometimes it might actually even be the same line. It could be like the creeks where the wall and the floor come together, and then there's a line that's in both of them and they're the same line. So I'm gonna put a big old sometimes there. So it says that you're doing all this. How about I'll just pick. I'm only gonna add one of these today. I need to look at the worksheet. I've got them printed out. Let's see. What does the worksheet look like? I actually think the worksheet might be the better one to do today, and then we'll do the textbook tomorrow. That sounds good. So today, get the notes done. Now, if it took you all period to do the notes, that's fine. We'll just pick up with the worksheet tomorrow. But if you get the notes finished, we're going to start this. We'll come back and do this tomorrow. And I feel silly not giving you homework, but I feel like we're moving through plenty fine. Like we're already in chapter 3, and it's just barely past the middle of September. Like it's not like we're gonna run out of time. We're gonna be fine. And I have not graded your test yet. I'm hoping today during planning period I got time to. But when I left at 3:30, that was one of the things that I just left sitting here. So now I'm gonna go grade squares and cubes quizzes and see, because this is the last one for their picking the high. So I'm hoping that we have some kids that it got better yesterday. But it was the last one, and that was the one that they threw in where it was like square roots and cube roots, and that threw some of them off. But I took no sympathy. I was like, if you can't do that, you really don't know. All right, I'm rambling now, so I'm going to shut up. So I hope all this made sense and that the worksheet looks good.